All right, so let's review real quick a few laws of exponents that we've talked about. Anything to the first power is itself. For example, 6 to the first power is 6. Anything to the 0 power is 1. For example, 7 to the 0 power is 1. Anything to a negative exponent is the reciprocal, or moved across, flipped over, moved across the division bar. So for example, 4 to the negative 1 would be 1 over 4 to the 1 is still there. You just don't have to write it. When you multiply exponents with the same bases, you can add the exponents. So for example, x squared times x to the third is x to the 2 plus 3, or x to the fifth. And when you divide exponents, you divide expressions with the same exponents, you can subtract the exponents. So x to the sixth divided by x squared equals x to the sixth minus 2, or x to the fourth. And again, I like to use the website mathisfun.com to get some of my definitions and examples from. They're very clear, they're searchable. So if you ever need to look something up, that's a good place to start. All right, so let's look at some examples from this particular IXL assignment, code L2J. All right, make sure you read the instructions carefully. Look at how they want the answer. So it says using positive exponents. So we know our answer has to have a positive exponent. So just always make sure you check that before you submit anything, so that you don't accidentally type something in and it's not in the format that they're looking for. All right, so let's just do this using the properties that we've learned for exponents. So when we divide, they have the same base. So when we divide two terms that have the same base, we can subtract the exponents. So 4 minus 5. So 947, 4 minus 5 is negative 1. So we end up with 947 to the negative 1 power, but they want us to use positive exponents. So we need to switch that. We need to flip that over. And now that 1 is positive. And we don't have to write the 1. IXL will not penalize you if you put the 1 there, so that's certainly up to you. I definitely wouldn't count it wrong on a worksheet or anything like that, because technically it's correct. It's just that every number would have that little 1 exponent if we were required to write it, so we don't do that. All right, next example. Again, read your instructions. They want positive exponents, so we'll make sure we do that. All right, again, we are dividing the same base, 796. We can subtract the exponents, 2 minus 7, and we end up with 796 to the negative 5th power. We're going to flip that over, just because of the negative exponent, and then the exponent becomes positive. As a reminder, notice that the base doesn't change. The sign of the base will never change because of this, just because of the exponent. So be very careful there. So now we have our positive exponent and we have our answer. All right, what about when you have multiple terms? You know, I say this all the time. The rules in math never change, and you know the rules here. All the bases are the same, and we're multiplying them together. So what can we do? Yes, we can add the exponents. So I'm just going to write them down just like they are. So negative 1 plus 8 plus negative 5. The base is not going to change, so I'm just going to write it down. Negative 1 plus 8 is 7. 7 plus negative 5 is 2. So all this can be simplified to 466 squared. All right, next example. I picked some that had a mix of stuff because a mix of multiplication and division, because A, that's what you're going to see too, and to show you that you know how to do this. As crazy as this looks, you now know how to do this. So just follow the steps, follow the rules you know. It's just like if you were playing a game or solving a puzzle. The rules are the rules. Math rules don't change. That's one of the things I like about math. It's pretty straightforward. If you know the rules, you can just about solve any problem. So there are a couple ways to do this. I'm just going to do the multiplication first, and then do the division. So I'm just going to carry the top term over without doing anything to it. And on the bottom, I'm multiplying so I can add the exponents. So what is negative 1 plus 50? 49. All right, so now I am accidentally erasing everything. Now I am left with just a simple division problem. The bases are still the same. So I can subtract the bases. 2 minus 49. I'm going to end up with 512 to the negative 47th power. And they want the answer with positive exponent. So what do I have to do? Well, remembering back to the negative exponents lesson, we flip this over. We take the reciprocal and we make the exponent positive. So again, all this can be simplified as long as the bases are the same. Okay, when we get to Math 1 and Math 2, we'll do some where the bases are not the same. But the rules won't change. The ones where they are the same, you know, we're going to do the same thing to them we've been doing. All right, last one. I picked this one just because it has both negative exponents, so it looks a little weird. But again, rules are rules. So bases are the same. We're dividing, so we can subtract the exponents. 949 to the negative 2 minus negative 4. Base is not going to change, so I'm going to go ahead and write that down. And if you'll remember, it depends on how you were taught this. But if you remember that minus, a negative negative is a positive, you can change those signs. So negative 2 plus 4 is going to be positive 2. Now, just to show you that worked out that way, let's look at this. If these are both negative, we could flip this over. We could invert it, and we end up with 949 to the 4th over 949 squared and positive exponents. And since we're dividing, we can still subtract. 4 minus 2 still gives us the same answer. So there are always a couple ways to do things. I try to teach the least confusing method, but again, it's not wrong to do it this way. I just wanted to show you that straight up properties are going to help you every time.